the sum of each of my inputs minus the mean of the inputs squared. And then sum it. So the summation happens after the squaring. Okay. Take each input, subtract the mean, square it. Input, subtract the mean, square it, then sum all those up. And then take the square root of all that. Okay. So S was 4.18. So let me try to get this in my calculator again. Number one, can you get the mean of the inputs for me? Up. How would you get the mean of the input list? Sure. Or you can just run one more stats. One is fine. I just need the first list. This mean is 81. Okay. Okay. So now if I want to get this number, I could take each value in list 1, subtract 81, square it, and do a sum. So let me see if I can do that in one step on my calculator. So I'm going to get that sum again. Get out of the light a little bit. I think I need another parentheses. I take everything in list 1. I subtract off 81. I square that, and then I sum that list. Got out the same number I got last time. I'm doing it right. Okay. Here's what I didn't do last period, is take the square root of that number. All right. The standard error of the slope is going to be S divided by that. Those would be the deviations from the mean of the inputs. And you get I get 0.3098. Okay to call that 0.3? All right. Here we go. We're going to do a confidence interval now. Least squares regression line. All right. Number one, talk about my parameter and my population. So I'm going to say we are estimating parameter. This time it's going to be slope. The slope of the least squares regression line of, okay, this data came from, it's the, let me read it to you. The distances are recorded as tenths of a millimeter in excess of 2.9 meters of the distance between where a point in the tower would be if the tower were straight and where the point actually is of the Leaning Tower of Pisa. Okay, so there's my population. So the slope of the least squares regression line of the let's see, what am I going to call this? Is lean of the Leaning Tower of Pisa. P-I-Z-A? P-I-S-A. P-I-S-A. Come on. Got anybody? No Italians in the class here? Okay. And these go for years. Okay. So there's some description of my population and a description of my parameters. Slope of a least squares regression line. Okay. Again, Alex, will you go back over to your side of the room? It's not going to work for you to share over here. It's too noisy. You're no Coco. All right, what's the word after? Leaning Tower of Pisa. Is that what? Yeah. For each year. Of the slope of the least squares regression line of lean. I don't know. I don't know what this thing is measuring. If I read a little more careful, I could read. I know what it's measuring, but it's kind of complicated. Can you guys be done with that? It's not a real easy thing to grasp. So, all right. My conditions. One condition I didn't give you yesterday, and I kind of like glossed over, was SRS. Yeah, so I'm going to call that condition number 0. Oh, wait a minute. I didn't name my test. Didn't name my procedure. We're doing a confidence interval. Let's do 95%. We're going to do a population slope of the least squares regression line. I'm sorry, of least squares regression line. My distribution that I get to use on this one is a T. Okay? My conditions. Condition 0, simple rounded sample. I start at 0 because yesterday I started at 1, so. Okay. Condition 1, independence of outputs, bless you. Okay? So these amount of lean from year to year need to be independent. I'm not so sure they are. I think probably how much it's leaning one year is dependent upon how much it was leaning the year before. So I'll just say maybe not. Okay? Condition number 2. Is this a linear relationship? How did we check for condition number 2 linearity? So just for linearity, the scatter plot is great. So let me get mine up. L1 and L2, zoom 9. All right. What's your thought? Look, the linear model would be fine for this. Okay, so let me copy that graph onto my paper, and it looks like this. Exactly. Okay. Next check is the standard deviations. So standard deviations, the standard deviation for the outputs needs to be constant. So with that, I check the residuals to make sure they're evenly scattered. So let me give you a little look at the residuals. Could you let me just show you, in case you forget, how to look at the residuals. And do a zoom 9. They look fine. They're pretty evenly scattered. I don't have some really close and some really far away. They're kind of far away, close, far away, close, far away, close, far away, close. Okay. Yeah, you don't want, a spray pattern, ladies, with your residuals. And this one I think is fine. It looks a little more spray the way I drew it. There, I'll put in one more dot so it doesn't look quite so spray. That dot isn't actually on my calculator, but I just put it in there so it doesn't look spray. Okay? Can I move to the next paper? Okay. Next is our normality check. This is condition number 4 for normality. And I do a box plot or histogram of the residuals. What do you want? You want a box plot or a histogram? You want a histogram? All right.